เคน่าจะถึงเวลาสมควรแล้วครับเดี๋ยวจะได้ขออนุญาตเริ่มนะครับโอเคครับขออนุญาตเริ่มนะครับสวัสดีนะครับผมนายเอกพันธ์ผู้เงินนะครับเป็นผู้จัดการด้านอุปกรณ์ครับของบริษัทประภัสสรนะครับก็วันนี้ได้รับเกียรติเป็นพิธีกรนะครับในการดำเนินกิจกรรมนะครับในวันนี้นะครับโอเคครับก็ก่อนอื่นครับขออนุญาตพูดแบบสบายๆกันก่อนนะครับขออนุญาตพูด agenda ครับแล้วก็ในส่วนของ schedule ในวันนี้นะครับทั้งผู้ร่วมประชุมในฝั่งที่เป็นออนไซต์และก็ออนไลน์ครับก็งานประชุมในวันนี้นะครับเราก็จะเริ่มหัวข้อนะครับในการประชุมนะครับโดยหัวข้อแรกที่เป็นในส่วนของตัว history นะครับกับตัว physical principle ของตัว Shockwave นะครับเราจะเบรกกันตอน 10 โมงนะครับในฝั่งของคนที่อบรมออนไลน์ครับในช่วง 10 โมงเราจะทำการถ่ายรูปครั้งที่1นะครับตอนนี้ทุกท่านน่าจะเห็นลิงก์ในการลงทะเบียนแล้วนะครับคนที่อบรมออนไลน์อย่าลืมลงทะเบียนนะครับเข้าไปในลิงก์นะครับพิมพ์ชื่อแล้วนะครับแล้วก็ใส่เลขใบประกอบให้ถูกต้องครับทีนี้หลังจากที่เราเบรกไปแล้วรอบแรกครับเราจะพักเที่ยงนะครับในส่วนของเวลาตอน 12 นาฬิกาครับจนถึง 13 นาฬิกาและจะทำการอบรมต่อในช่วง 13 นาฬิกาครับและทำการเบรกรอบที่2นะครับในช่วง 14 นาฬิกานะครับและทำการถ่ายรูปครั้งที่2นะครับสำหรับผู้ที่อบรมออนไลน์นะครับหลังจากนั้นนะครับเราก็จะทำการนะครับในการอบรมต่อในช่วง 14.15 นะครับนาฬิกานะครับอบรมในช่วงบ่ายที่จะเป็นในส่วนของเวิร์กช็อปนะครับแล้วก็จะจบการประชุมในเวลา 16 นาฬิกานะครับโอเคครับเพื่อไม่เป็นการเสียเวลาครับอย่างนั้นขออนุญาตกล่าวเริ่มนะครับเพื่อเริ่มต้นพิธีเปิดนะครับโอเคครับเดี๋ยวขอเชิญนะครับนายชนัทนะครับธนุวงศ์การค้าครับกรรมการผู้จัดการสหคลินิกกินเบลนะครับมากล่าวเปิดนะครับในการประชุมวันนี้ครับเรียนเชิญครับ
สวัสดีนะครับก็วันนี้นะครับก็ Green Bell Medical Clinic นะครับก็ร่วมกับมหาวิทยาลัยคริสเตียนนะครับแล้วก็ต้องขอบคุณบริษัทประภัสสร Engineering Supply นะครับที่เป็นเชิญวิทยากรมาให้เรานะครับก็ในหัวข้อวันนี้นะครับก็คือเรื่องของการรักษาด้วยคลื่นกระแทกนะครับหรือว่า Shockwave Therapy นะครับในหัวข้อ The Role of Shockwave Therapy in Regenerative Medicine นะครับก็ต้องขอบคุณนะครับดร. Andreas นะครับแพทย์จากประเทศเยอรมนีนะครับที่มีประสบการณ์เกี่ยวเรื่องของ Shockwave มาอย่างยาวนานนะครับแล้วก็มิสเตอร์พีเตอร์วาลอนนะครับซึ่งพีเตอร์เนี่ยเราก็รู้จักเขามาเป็นเวลานานแล้วนะครับก็แกก็เป็นผู้เป็นทีมที่ทำ Shockwave ตั้งแต่ 20-30 ปีก่อนนะครับก็แล้วก็สุดท้ายก็ต้องขอบคุณพิธีกรของเราวันนี้นะครับเราจะทำการบรรยายในภาษาอังกฤษนะครับโดยที่จะมีคุณอิรีนาชวานะครับเป็นผู้ดำเนินรายการนะครับยังไงก็เชิญรับชมนะครับได้เลยครับขอบคุณครับ
โอเคครับต่อไปจะเข้าในส่วนของการบรรยายแล้วนะครับก็จะขอเริ่มต้นจากคุณอีรีนานะครับก็จะเป็นในส่วนของเซลล์มาร์เก็ตติ้งนะครับบริษัทเลกเมดนะครับจะอินโทรดักชันนะครับให้ทุกท่านทราบเกี่ยวกับเรื่องของบริษัทเล็กน้อยเทคโนโลยีเล็กน้อยนะครับแล้วก็ในส่วนของวิทยากรนะครับในวันนี้นะครับก่อนที่จะเข้าในส่วนของการบรรยายจริง
Good morning, everybody. It's a pleasure for us to be here with our team. I really like Bangkok, also my colleagues, and your food. And Thai food is really nice. So, yeah, last year we've been here, and it's really nice to be here again. Thank you. Today, we would like to present as a short introduction our company, and of course afterwards we will move to our main topic. But for the first I would like to talk a few words just to say about our company, where we come from, and who we are. Our company was founded in 1978 by Mr. Rudolf Lieb, the father of Sebastian Lieb. Sebastian Lieb is on the left-hand side in our executive board, and also Alexander Gromont on the right-hand side is as well our CEO. Our company, located in Eppingen, south of Germany, really nice place with vineyards, so you can also drink a good wine in that area. And it's not far away from Frankfurt Airport, some round about 1 hour to drive by car, so just to estimate where we live and where we work. Our promise, made by Likamed, made in Germany, focus on design and quality, and this is what we would like to present today to you. So here just main contacts. Shanat already introduced myself. I'm Marina Schwer, Head of Sales and Marketing. Once again, really nice to be here. And Alexander Gromont, our CEO. Last year, he also visited Thailand together with me, and we did very good workshops for Shockwave device. Yes, and of course, the main participants of today's workshop, Mr. Peter Vallon, our father of the Shockwave device. He used to work for more than 30 years at Wolf Company, and we are really pleased that since 2012 until today, he is head of research and development at Likamed. So just to keep you on track, this is Mr. Vallon with the glasses. Just 2 days ago, as you can see. Yes, it was the first prototype for lithotripsy Wolf Germany, but of course Mr. Vallon will talk about where he came from, what he did after my short introduction. So I think be excited. And Dr. Andreas Lang, he is our specialist in orthopedics and trauma surgery, also a part of our medical team and a main user for our Shockwave device since years. So he's really an expert at this field. Also be happy to have him during our business trip here. And of course, very important, Professor Dr. Dukschein. He is also a part of our medical team, professor from the University of Hamburg, and where all our studies come from, Professor Dr. Dukschein. So if you are interested in studies, and I think maybe most of all have them, also Shanat and the team Prapatson can share all the studies with you. We are Likamed, over 40 years experience, so you can see our employers and some of the pictures of our production site. We are very proud to have our own eco-friendly powder coating, which we use for our products. And of course, engage and qualified employers, so this is really a most thing. Made by Likamed, made in Germany, we really develop, test, produce, and assemble everything in Germany, 100%. And we have all the certification to supply in our products, and also the main, I think you're aware about TÜV Süd. I think this was also there is also in Thailand, this company, so we are really proud to have all of these certifications. Where we come from? Actually, our main field, our first field, what we develop, medical chairs. And medical chairs, of course, the main field is dialysis, but we also produce the medical chair for different fields, not only dialysis, like oncology, blood donation, infusion transfusion therapy, and many more. And the second field, why we are here, it's our Shockwave devices. So for orthopedics, physiotherapy, trauma surgery, cosmetics, veterinary, and many more fields. So far, short introduction about our company, our team, where we come from, what we do, and I'm really happy to hand over to Mr. Peter Vallon for the main topic of today's presentation, the role of shockwave therapy in regenerative medicine.
So good morning, ladies and gentlemen. My name is Peter Vallon. You hear it from Irina. And I'm here to talk about the shockwave or my life with the shockwave. Just now, it's 40 years ago, I started in Richard Wolf after university. I started in Richard Wolf to develop a new shockwave. At that time, I really started at the beginning, so I even didn't know that the human has 2 kidneys. I have to learn it. I thought only one, but fortunately I found out I have 2. I was very happy to do something for the medicine which makes sense, and Richard Wolf was close to the area where I was living. So I found we had in the university already, we discussed about medical research, and so it was very nice that I could come to Richard Wolf and start in Richard Wolf. We were only 2 persons in Richard Wolf, 2 engineers who started with, actually nobody thought in Richard Wolf that we will be successful, because why? What was the reason? You see this machine, this was Dornier, old lithotripter, the first lithotripter from Dornier. They had no competitors, sold quite a lot of machine, and that was the beginning with Dornier. A big machine, expensive machine, and we from Richard Wolf thought we have to find a way to design a machine which is not so expensive, which is also not so, the running costs are not so expensive. Why? You need always degassed water around about 500 liters. You need full anesthesia, you need anesthetists, and you need doctors, you need engineers or technicians to change the so-called spark gap in the machine. So the team was rather big and the treatment was rather expensive. So we said, okay, what can we do? And we designed a much more smaller machine, not by a spark gap generating the shockwave, but by piezoelectric. Piezoelectric lasts longer. We didn't have to change, was not necessary to change the spark gap, because the dish, like we call it, of piezoelectric lasts quite 5 million shockwaves, and it was a great advantage. The costs was cheaper, the running costs were cheaper. Also the machine, only a third of the Dornier machine. So after 3 years, we were developing, we appeared on the market, and Richard Wolf sold quite a lot of machine. During my 30 years I joined the company, we sold 750 machines. Only a little bit history from Wolf. And of course, during that time, we go also to the ESWT, and maybe somebody of you know the so-called piezo zone, piezo wave 2. I worked until end of 2011 in that company, and also this is my design. Also the name, I give the name piezo wave, piezo zone. Piezo lith was a big machine, and until now they are selling this machine. I'm also very proud of that. But I know Licamed before, because Licamed was also planning and designing a table for the lithotripter for Wolf. So I had connection before to the CEO from Licamed, Rudolf Lipp, and so I said, okay, after my retirement, early retirement in Wolf, I continue working and be developing. Why? I did it because already in Richard Wolff I thought I have a lot of knowledge and I want to change some things. It was a little bit difficult to change the machine from Richard Wolff because it was running well. And so I used the time in my new company, Licamed, to give all my ideas, all my experience in our new machine called Shockwave. So that means we found later on, I will speak about this machine, what are the advantages and so on, but later. Before, I want to talk something about the system, how to generate the shockwave. There are normally 3 possibilities. This is a so-called focus shockwave. On the left side, you see the piezo transducer or piezo generator. Then here, electromagnetic. This is a coil with high voltage and with a so-called ellipsoid, and you have a focus point where you collect all the energy in a focus point, and you see, we call it indirect. First the wave goes to the side and then go up. The same you see here in the Dornier system, also ellipsoid. It's not so-called direct focus, it's an indirect focus. The only transducer with the direct focusing is piezoelectric. What means that? That means if you focus direct, you have a smaller focus point. If you focus indirect, not directly, you see you have a so-called reflection, you have a bigger focus. Yeah. Oh, sorry. Now it comes to ESWT. Why ESWT? We found out that the shockwave, not only we, also competitors found out that the shockwave you can also use for indications, for example, in the orthopedic field. At the beginning, we thought that you can break with a lower intensity of the shockwave calcifications. For example, in the body, you have some calcification. Mainly well known is a calcification in the shoulder. And we thought at the beginning we can break this calcification. It was not like this, but Dr. Lang will explain why it was a misunderstanding. We didn't break it, but we thought it can happen. So we said, okay, we can use also a lower intensity of the shockwave for breaking calcification in the body, for example, the shoulder. Dr. Lang, after my speech, will explain that it was not really true. I come back to the Shockwave. The Shockwave is a system which is a focus system and a radial system. Later on, we will speak about this. Also, what is the difference between all system, the competitor, and our system? There is one big difference. I want to tell you this in advance because this is our main purpose, that we have a different shockwave. That is what I always want, a system which you can both do, not only focus, not only radial, you can do both. But later on I will talk about this system. Maybe you have already now some questions regarding the system, the generating of the shockwave, or for example about different system, and later on I will come direct to our system. This is only now an overview of different shockwave systems which we can use, but later on we will detailed go to our Shockwave system, what are the advantages, what are the physics behind, and what are the techniques behind. Maybe now you have some question. I'm waiting for your question regarding the different shockwave system, the different generators. and please ask me. You can ask me all questions. I think I have 40 years experience. I think I can, I hope, and I'm quite sure that I can answer all your questions. You can, I think, if not in English, we have also here somebody who will translate. Ben will translate if you want to use another language. Yeah, okay. We have also our online interesting people who want to know. Maybe they can put the question online, but until then, maybe you have any question about the system, different system, which is better, which is not good, which advantages, no advantages, regarding the Shockwave system. And later on, we will come to our Wave. But now this is only an overview of the normal systems. Online, no question. If no question, that means that everything is clear. So I did a very good job. Thank you very much. We will continue. Now I want to introduce one more time Dr. Lang. He is not here. Of course, he disappeared. Nobody knows why. He will talk about the medical effect of the system. So, but I can also, shall I continue with because if not, I go on fast, no problem, moment. So we have, now he's coming. Okay, he's coming, then he will continue. If not, oh, here. We are looking for you, Andy. But you disappeared. He was hungry, maybe. Eat something. Okay, Dr. Lang.
So hello everybody, sorry for the delay. I'm Dr. Lang. Originally I'm an orthopedic surgeon and I work on that field since 1986. And I started to add Shockwave to my daily work since 2003. And first mainly used Regenerative system, piezo. And from 2013 or 2014, I started to use the Wave machines. So I know all about the evaluation or the history of Ligamed machines too. Okay, you know that the origins of shockwave therapy are in the lithotripsy, as Peter Vallon told you before. And beside that, the users saw that the shockwave caused some effects on the bone, what was within the field of using lithotripsy. And so people got to know, or scientists or physicians got to know, that we might an effect of the shockwave therapy of shockwaves on tissue. First, the concept was to treat diseases with calcifications, like in the shoulder or at other parts of the body, let's say at the Achilles tendon insertion and things like that. And people tried to destroy these calcifications similar to the destruction of kidney stone. But in later times, ongoing at the beginning of the 90s, we found out that not the cracking of those calcifications was the healing process, but you use shockwave therapy, you enhance the body to go on with the healing of those calcifications and to solve them. But the thing is that the shockwaves used in the orthopedic or medical field beside the kidney stones don't crack calcifications, but they improve the, let's say, self-healing mechanism of the body to get rid of those calcifications or to heal insertion problems of tendons, like plantar fasciitis, Achilles tendonitis, and as I mentioned before, calcification of the shoulder. So today, shockwave is used in a various fields as a non-invasive treatment option for various musculoskeletal disorders, and that was the interesting point for me, who uses the knife for solving medical problems, and now we found means for some for a non-invasive treatment for disorders who was operated on in before. That's the picture that was no, it goes the wrong way. It goes the wrong way. Okay, now the medical effects. Okay. Shockwaves induce cellular reactions and leads to tissue regeneration. And one point is that it was found out that the stem cells were activated. Lymphoangiogenesis and angiogenesis is promoted sometimes. Sometimes you see less vessels in the tissue, because vessels sometimes mean that the inflammation is going on, and when the vessels are reduced, the inflammation disappears. The blood flow and the microcirculation is increased, and beside that, there are certain antibacterial and other anti-inflammatory effects. Meanwhile, there exists some basic research findings, and I want to show you one studies what found out some really key stones or key findings for the effect of shockwave therapy. Together with Professor Duckstein, there was a study by fibroblasts, fibrocell monolayers on petri dishes, and the method of analysis was to find out if you could promote a migration of fibroblasts by shockwaves. And we wanted to find out which is the best energy to applicate and which is the best frequency to make the fibroblasts be active. Fibroblasts, I think you know, are cells within the connecting tissue. Okay, and frequency between 4 and 6 hertz was used, and or it was found out, I'll show you later, that the frequency between 4 and 6 hertz is the best frequency, and the number of pulses is 500 to 2500 to treat 1 point, and the best energy flux density is between 0.06 or 0.1 and 0.3 or 0.32 millijoule per square millimeters. And on this shield you see the main result of these studies. To explain, is this the laser? Okay, no. Is there a laser? Ah, the red one. Okay. Sorry. On this slice you see the fibroblast layers. The black areas are living fibroblasts, and in the red areas, the red cross, there are no more cells or dead cells. Okay, you caused let's say, an artificial wound by scratching this cross on the petri dish. There were no more living cells in this red cross. Okay, and if you leave it for 24 hours, the remaining fibroblasts they react and they grow, and without Shockwave, it's like that. Just remaining red spots. The gap isn't filled, and if you use Shockwave in a certain manner, then from this red cross, the wound within 24 hours nearly healed because you see only a few red spots. Okay, that's the picture of the result. Okay, good. Can you go on one? Okay. And that's the table for the results. A lot of numbers, I know, but the light blue area is the interesting area. And you see on the very left side, that's energy, then the frequency and the applied pulses. And you see in an energy between 0.1 and 0.2, or there are the best results, because on this side you see the remaining area without living cells. Let's say here energy 0.1, 4 Hertz, 2,500 impulses, 11.21 remaining field without cells. Okay, if the energy or the applied pulses is too low, like here, the area is bigger, there are no cells, and if the energy exceeds a certain point, the area again is bigger because the energy was too high. If you use too high energy on cells, you kill the cells. So we could find out that there's a certain range of frequency which is good for the cells, and a certain range of energy input that is good for the cells. Too low energy, too low frequency, no effect. Too high energy and too high frequency, you kill probably the cells. Okay? If you have questions so far, you can ask. Otherwise, we have time to take questions whenever you want or afterwards. Are there so far any questions now? Okay. Shockwave sources and different types. Peter Vallon told you about that. The piezoelectric, the electromagnetic, the electrohydraulic sources, the classical, let's say, focused sources. You know, there's a difference. On the one hand, there are the focused shockwave sources, and on the other hand, there is the so-called radial shockwave. What is the really innovation of the new machine is that this new machine, to say it in front, but I explain it later, is that you have both one machine and you can get deep into the tissue, and you can have a certain amount of energy within a volume, not only in a one deep focus point and not only on the surface, but in a volume in a certain area. Okay? Peter Vallon, I think he explained how his machine worked. It's worked similar to a radial machine. The projectile is accelerated. Should he explain that? It's your turn again. Okay, so I just switch up to Peter Vallon. That he's the engineer and I'm the doctor, so he can tell the basic physics better than me.
So, Dr. Lang, thank you. Thanks a lot. But he knows also he's a doctor, he's no medical and physical, he knows everything. Because he worked long time also with the Wolf system. And, one second. I have to go back. Therefore, no problem. I explained before, we have shockwave, how we generate the shockwave, piezoelectric, electromagnetic, and electrohydraulic. So, and now it comes to our machine, Julega Wave, what we do or what technique we use. That is a so-called ballistic or pneumatic generation of the shockwave. And we have, one thing is very important that you know. Look, everybody said this is, let's say, radial. Generating the shockwave has nothing to do with radial or focus. This is very important to know. Generating a shockwave, you can do it with piezoelectric, you can do it electrohydraulic, you can do it electromagnetic, the generating of the shockwave. We generate here it with air, pneumatic, and the output could be radial, but not must be. Could be, yeah? Depending on the system, what is inside, which technique are you using. And there's a different technique, only an explanation, short explanation about the competitor. You want to also know what other companies are doing. They have a projectile which is made of metal. Metal runs in a metal tube. In front, it goes in one direction. This is a laser pointer. It runs in this direction until this point here. But then it has to come back because the next shot has to start from here. Air come in, runs to here. Now it has to come back. The other companies, the competitor, they do it with a spring. In front of here, you have a spring and it moves the projectile back. So now Ligamate has a different system because a spring takes the energy away. We don't want, or takes a part of the energy away. And we do it like that. We use also air. Then we have another valve, and we go inside of here with the other air channel and open the valve, and then we have here a small hole which push the projectile back. We do it not with a feather, because if this comes to a feather, you lose some energy. Feather makes like a brake. But we use the air to push it back. Therefore, we generate a lot of energy more than the competitors. That was my idea. Yeah. Not to use a feather, but use air. And air, you can make a higher pressure. When you make a higher air pressure, the production is faster. If you have only a spring, the speed is always the same because you don't change the mechanical system of the spring. Very important to understand. Ligamate uses air pressure, the other uses a mechanical spring. Therefore, we are faster. And what happens if you move this in a faster way, the output is bigger, is higher. You get more energy. For our system, very, very important. The next step, because I want to explain you the difference between those systems with our competitors, which we like also, but we like our more, of course. We have here no metal on metal. If metal runs on metal, you have a resistance. We use here a special ceramic, which we developed. We get ceramic a higher speed first. The second thing is the duration, the running time is much more longer with a ceramic than with a metal. And you get no corrosion, because inside, if you make something pressure, you get a kind of fluid, a kind of water inside. Water, water and metal, this metal ball gets a little bit corrosion, rusty, and this rust is inside, which lowers the speed of the projectile. That is very, very, very important to know these two, that this makes a big difference. Why? We have a lot of energy first. A lot of energy makes also we compress the shock waves to a smaller area. Therefore, we call it wide focus, because later on you will see the angle. We have very small angle. We have like a focus because we compress the shock wave in a smaller area. The other have a very big angle. You will see it later. There's no compression. That means the penetration of the shock wave is in a radial system, only maybe 10 centimeters, 15 centimeters. And we have maximum 55 centimeters, because we are generating the shock wave in a different way by using here a ceramic, by using here no feather, but we use the pressure. We have a valve who leads in here the air. If you see, there's a small hole inside and brings the projectile in a fast way back. This is a big difference, which is very important to know. You see, again, focus shock wave. You have here the focus point. This is the focus point. The focus point is fixed. You cannot change it. It's a fixed focus point. If you use, for example, electrohydraulic, electromagnetic, or piezoelectric system, you have a fixed focus point. So, radial shock wave, look, I mean the angle is here. This angle and this angle is very big. So the energy is here, all big area of energy. Yeah? Advantage, deep penetration depth, high pressure. And here you have easy to aim, of course, because this is bigger, but you have low penetration. Very important. So, and now the further explanation. Again, we see here the focused area. We see here the angle, a big angle, and you see here the wide focus. And we have here a small angle because we compress the air due to our high energy and due to our special ceramic projectile and our special mechanical system. That is all patented, so of course not allowed and not possible to copy our system. The next one are real measurements in so-called degassed water. To see the effect better, it's important to have degassed water. And these are normal pictures. With special cameras, we make these pictures. You have here the focus system. You see here the focus point, which is a small area, and the energy starts not here. Here is the body. Here is the body. The energy starts here, and you have here focus. In the focus, you have a very big energy, of course, a concentrated energy. It's difficult to find the depth of the region of interest of the problems. So you have here, you have to say to the system how deep you want to put the focus in the tissue, in the body. This is here. This one is a radial system. You see in the color that the energy is smaller. Red means very, very high energy. Green, yellow means not so many, but still in this area you have energy in this blue. But not much, of course. You see, here you have not many energy. The penetration, this is the line, the x-axis, this is the line of the penetration. You have here maybe 10 centimeters here until the yellow one. 10 centimeters, 15 centimeter maximum. So, and you see also the shock, this is a shock wave, and this one is a so-called pressure wave. That means even if you look here, you see this is not a shock wave. This is a so-called pressure wave. A shock wave looks like this with a very fast, what you call it in the technique or the physics, a rise time. Rise time is here you go up very fast. And now you have the Licamate focus system. You see, we go also up. That is a curve. If you see here, we start in the skin also, but we can go up to, depending on the applicator, small applicator. With the smallest applicator, we can go 55 millimeters. There we are using the middle size of the applicator. But you see, even here, until 55, you see a signal, and with a small applicator, you can go on 55 millimeters. Why we call it wide focus? Because the concentration of the energy is not a small focused one, it's rather wide one. That means advantage. You don't have to know the exact depth of the indication or the region of interest. Here you know the exact, because if you are in front of the focus or behind the focus, zero energy. That means you have to localize exactly the depth. And this is rather difficult because in this small machine, we have no X-ray or ultrasound. We have to guess how deep it could be. And here, you have all energy here, so we are quite sure that we reach the right depth of the energy. One word to our system, why we can apply this high energy, how we manage it. We manage it because we have the so-called vario focus. Vario means we go up with the energy. During we are up with the energy, the frequency is low. So the patient or the cells have time to relax until the next pulse is coming. Frequency low means the pulse is slow coming. Low energy means the cells can relax because they are not so hit with the high energy of the shockwave. And that is very important, our different vario mode, that the patient can accept this higher energy. If not, if you have only linear focus, you put always with the same frequency, with the same energy, always one spot of the cells, and this can harm the cells. Not kill the cells, but harm very hard. Patient has a lot of pain. Due to our vario mode, the patient can relax during these different periods where energy or frequency are low. Very important to understand. What is our different? We have a ceramic which creates another shockwave pulse. Second, we put our projectile back, not with a spring, but with a special high pressure. With a valve, we switch the valve over and go with air inside, and air presses this projectile back. With a competitor, with a spring, where you are losing energy. We have a vario mode that makes possible that we go higher with the energy, due to go higher to the energy and lower the frequency. The impulses are slower, the cells have time to relax, and the patient doesn't feel so much pain. This is also very important. Of course, that was my experience during my 40 years working with a shockwave. That was my experience, and I want all my experience put in our new system from LicaMed, the LicaWave. And I found out that a focus point like this, a focus point like this is good. You have a lot of energy, no question. But if you cannot position this focus point exactly, then you have the so-called in front focus or after focus. You have zero energy. That means if you treat a patient, you could be only successful if you find the right depth of where you put the energy. And this is guaranteed with our system, because we have here all energy. Here until here, 55 millimeter maximum if you use the smallest applicator. These things are really very, very important to know. It is very, very important, because I want what I learned, my experience, I put in our machine, in our new machine. And of course, I want that the customer knows this, because it's very important for the success in treating patients and for the good results. So now I hope you have a lot of questions, because maybe I didn't. You know, if you always every day work with the Shockwave, you think all the person know everything. They are thinking like me, but they don't think like me. You have to ask me, because there is no stupid question, you know. It doesn't exist. Please ask. You can also ask. We have also Ben here who can translate if you cannot ask precisely in English language. Ask in your language, and Ben will translate it. But even now, who has questions? It's not possible that you have no questions. I'm not so good that I can perfectly explain. I know it. You have to tell me what you want to know. Go deeper in the thing, because it's not so easy to understand. I know everything because I work every day with this. But for you, it's not so easy to understand. This is quite normal.
So there's one question from the online meeting. Yep. So the question is, what's the difference between radio shockwave and deep friction technique? What's the difference between shockwave and deep friction technique? Deep friction technique. It's the massage technique. Deep friction. Deep friction. Yeah.
Das ist Physiotherapie-Technik.
So.
Deep Friction Technik.
Ach, Deep Friction. Ja.
Shall I answer?
Vielleicht gibt's noch technische. I want to, if you have not more technical question, then Dr. Lang will answer. This is a medical question. Yeah?
But I can answer it. It's
you can
easily to answer.
Okay.
Hello again, it's me. I'm the doctor, so I know a little bit about that. Deep friction technique is, you can say, a little bit similar to shockwave, but shockwave is much more precise and much more. You can put much more energy into the patient, but it's right from the mechanical aspect. It's a little bit similar. But how knows a physiotherapist how much energy he puts into the body? With the machine, you can calculate a little bit more. But with shockwave, you put mechanical stress on the tissue. That's called mechanotransduction. And if you put a finger on and press hard on tissue, it's a mechanical stress on a tissue too. If you go out and make a run for 5 kilometers, you put mechanical stress on your body. It's mechanotransduction. There's always an answer of the body for this mechanical stress. So in a wide field, you can compare deep friction massage to shockwave therapy. That's right.
Yes, thank you for the answer. And there's one more question from the online meeting. The question is, can a wide focus cause skin irritation?
The wide, of course, the question if wide focus therapy makes any or harm the tissue. If you treat, it's possible that you see a so-called red point on the tissue, but it's after 5 minutes you see nothing anymore, 10 minutes you see nothing anymore. What is the most important thing? The most important thing that you are using enough gel. Gel is a medium to transport the shockwave in the body. If you have no gel and you have air bubbles on the skin, then all the energy remains on the skin of the shockwave. So put enough gel is very important. I even heard the question that sometimes the doctor asks why we have to put gel on the skin. Because the gel transfers the shockwave in the body. So most time it's only a question of the gel. No gel, of course.
Thank you.
Please give an example for the patient who used wide focus. Can you explain the patient how patient use wide focus more effective?
Why, if I understand
Wide
right,
focus invention.
why wide focus has
yes.
more efficiency
It's
than the,
appropriate for the type of patient, musculoskeletal or myofascial pain, or
yeah,
for example.
the most important thing for the wide focus and for more efficiency are 2 points. If you use a focus system, as I told before, you cannot find the exact depth of the focus. That is one thing. You cannot find. Why? Because you have no localization system. You only can think must be from your experience. Maybe also Dr. Langwille, he has a lot of experience. He knows shoulder must be, I said 20 millimeters. He used a 20 millimeter. Then he can use a focus. But sometimes you don't need, depending on the indication, you don't know the depth. And therefore, with our system, once again, so I want to show, with our system, you see, here you have a depth, you have shockwave energy all the way along. Here, you have to go only, you have the shockwave here. That means you have to exactly know how deep you have to go. And if you see the radial system is only 10 or 15 millimeters. So you cannot reach with the radial system our wide focus because you have no energy here. Here you have energy. Here's no energy. Yeah? And once again, with the focus system, you have to position the focus system very exactly. Is it okay for you? Yeah, yeah. Yeah, please. The contraindication. This is Dr. Lang.
That's a good question, because in former years there were some contraindications. If the patient uses drugs like Marcomar, like anticoagulation medication, you shouldn't use it, and you shouldn't use it on vessels, you shouldn't use it on nerves. But that was, let's say, old thinking, because if you combine, if you use an energy like the lithotripsy energy, this is up to 4 times higher than the energy which is used now for extracorporeal shockwave therapy on the orthopedic or other medical fields. Okay, and with these low energies compared to the lithotripsy energy, you nearly can do no harm to the body. In former times, you shouldn't go use shockwave when there's underlying lung tissue, but you can use it. Nowadays, there are only rare contraindications. You shouldn't use it in cancer. That's an old contraindication, and nobody proved it right why you shouldn't use it. You shouldn't use it on pregnant women directly on the belly, then on the baby, but nobody proved it why. But some, for example, nerves. In former times, it was said you shouldn't use it when a nerve is underlying, perhaps on the carpal tunnel side. Nowadays, some of my colleagues, they even use shockwave therapy with the energy for musculoskeletal disorders to try to make a therapy for carpal tunnel syndrome. Okay, so the contraindications are cancer, pregnancy.
So any questions more?
More questions from the online meeting. So because of the wide focus can can cause the deep penetration in case of treatment around the thoracic area. Will there be any side effects or any harm to the visceral organs?
That's a similar question to that one. With that energy you can create by, let's say, the normal or the shockwave machines used for, let's say, orthopedic indications, the risk to harm tissue is very, very low. In former years, with lithotripsy and the very high energies, you found hematoma, and that means rupture of tissue. Nothing starts to bleed if the tissue is not ruptured. So, but nowadays I have the experience in shockwave therapy, as I said, since 2003, and in ligament systems since 2013, and I hardly see one, let's say, superficial hematoma under the skin, but that is due probably to skin in an elder person, and you can touch it and immediately there's a bleeding under the skin, but I hardly see that. It's very rare that I see a tissue damage during using shockwave therapy in the field where I use it.
Okay, so for more questions, so they ask, will the shockwave can cause pneumothorax or not?
What?
Can shockwave cause pneumothorax?
Oh, I didn't get that.
Yeah, can it cause pneumothorax in patients?
Pneumothorax? Or what?
Yeah, pneumothorax.
Pneumothorax. Pneumothorax. Okay. Pneumothorax. Sorry. On a translation, it was the German word, so I know it. Okay. That was in former times. If you use very high energy, you can use a pneumothorax. That means you rupture lung tissue, and you may cause a very hazardous situation for the patient. No, with those machines used in the musculoskeletal field, you cannot create a pneumothorax. Okay, our machine exceeds, what is the highest energy you can create? It's 0.8 millijoules.
0.89
maximum. But depending on the indication, in my hands, I don't exceed, let's say, 0.3. I can show you later a case of clavicular fracture, delayed healing of a clavicular fracture, and that's near to the lung tissue. And with the energy you use there, it's not possible to create a pneumothorax. So there's no contraindication.
So we have further questions? Yeah. You have also one. Which one first?
Yeah.
Online, okay.
Okay, online first, please. Could you recommend the initial frequency and energy settings for a patient who is using the shockwave for the first time? Could you recommend the initial frequency and intensity for the patients who use shockwave for the first time?
Yeah.
Later on in the workshop, you'll see that, and that's a good thing you can do with the Shockwave system. I first use when there comes a patient for the first time for the first treatment. I put on the linear mode and put it on frequency 4, and then I exceed the intensity up to that point that the patient says, I don't want no more. And then I switch to the vario mode, and I tell you later why the vario mode is a good one. In former times when there was no vario mode, I did it the same. If you probably has a very, very acute epicondylitis, you probably can only go up to 2 or 3 of intensity. In former times, I tested. I started with 0 and put it on 1 and 2 and 3, and the patient said, let's say at 3, no more. Then I start with frequency 3 and linear mode in former times, and started the treatment. And it's like this. At the, let's say, first 500 pulses from 2000, the patient says, oh, it's really hard, but I just can't stand it. And if you give more pulses and more pulses, the pain, the initial pain goes down. And my explanation for the patient is then, it's as I give you an analgesic drug. It's a mechanic analgesic drug. I start at that intensity that patient dares. And in the next treatment, you begin at that energy, and often it's like this. He can bear a higher intensity, so I exceed the intensity. But on the first treatment, I've tested by linear system how much he can bear. And it's a very individual thing. It belongs to the person, it belongs to the disease that you treat. It's very individual, and you have to individually find it out.
Thank you.
Thank you very much, Dr. Lang. I want also to tell, this was a medical side, which is more important than my opinion. But I come now from the technical side. We have such a kind of recommendation in our machine. That means if you treat shoulder or heel spur, whatever, you can choose the indication, and then you have a recommendation. But I think due to each patient has a different pain feeling, it's better the doctor's opinion. I agree more to the doctor's opinion, because this is only the average. But if you start with a machine, you can start to use this and then find your own experience. But I think the doctor's explanation was very good. So follow him, not me.
I just can add one little sentence. Peter thought of the recommendations within the machines. If you have the machine and you click on an indication or on a location on the body, they show you, it's shown a recommended frequency and a recommended intensity. But for the first treatment, be very careful with that. You can try 10 shots or something like that, but if the patient says no, you use my way to treat.
One more question, please. Is it true that the Shockwave is the best for my musculoskeletal treatment?
For what treatment?
Is it true the Shockwave is the best for skeletal muscular disease?
Let's say it's a very elegant and non-invasive treatment, but it's no painless treatment, okay? But it's true, even if the patient you can try it at your own body. I often try it at any problem I have on my own body, let's say muscle rupture, anything like that. You can try it, but I never saw a severe side effect. So it's a very good way to treat a lot of musculoskeletal problems. And if anybody asks me, can I use it for this disease and for this disease? And I say, try it.
So we have some further questions.
Last question before the break.
Last question, yeah.
Okay. If we apply the shockwave around the shoulder area, can it damage the bone in the ear, in the inner ear?
What do you mean?
Bone in the
Bone in the ear?
Yeah.
One fast answer, no.
Maybe we have to tell the question because nobody knows the question.
If you treat the shoulder region, if you can damage the bone around or in the ear, and I exactly say no. No, you can't damage you can't with these machines for musculoskeletal disorders. Even if you put on the energy what you need for bone healing, you can't damage the bone. You can't damage the bone. Even if with the energy of lithotripsy, you don't damage the bone, but the bone reaction you saw during lithotripsy was not damaging of the bone, the bone was growing. If you see it on an X-ray, the bone is, let's say, gray, and when there's a lot of bone material, the bone on an X-ray is white. So what the first therapists saw, when they cracked kidney stones, they saw that the bone of the pelvis got white. So there was more bone material after that. But you cannot crack bone with shockwaves.
So that means maybe the ear becomes bigger. Huh? No joke. And I think, is it right that we make a short break now? Or yeah, short break from 15 minutes. Or?
โอเคครับก็ขอบคุณมากนะครับในเซสชันแรกได้ไงเดี๋ยวคำถามที่ยังค้างอยู่ทางออนไลน์นะครับจะมาตอบต่อหลังจากเบรกนะครับเดี๋ยวเราเบรกกัน15นาทีนะครับในฝั่งออนไซต์มี Coffee Break ทางด้านนอกนะครับเดี๋ยวเจอกันตอน 10:15 ครับทางออนไลน์ครับเดี๋ยวขออนุญาตให้เปิดหน้าจอนะครับทางออนไลน์ทุกท่านนะครับเปิดหน้าจอนะครับเราจะทำการแคปหน้าจอนะครับเพื่อเป็นการทำขอคะแนนนะครับโอเคครับขออนุญาตทุกท่านนะครับเปิดหน้าจอนะครับทางฝั่งออนไลน์นะครับโอเคครับมีทั้งหมด7หน้านะครับอย่างนั้นขออนุญาตเริ่มถ่ายรูปนะครับตั้งแต่หน้าที่1นะครับโอเคยิ้มนะโอเคครับหน้าที่1นะโอเคเปิดค้างไว้ก่อนนะครับโอเคสักครู่นะครับรอสักครู่นะครับพอดีหลายหน้าโอเคครับแคปหน้าจอเรียบร้อยนะครับขอบคุณทุกท่านมากครับเบรก15นาทีนะครับเจอกันตอน 10:15 นะครับ